systems and programming, and we will go through the section of the theory, which will include like the basic introduction of computer systems, like what it constitutes of, what are the main terminologies we use in the computer, what are the operating systems, inputs, outputs, and everything related, the very basic introduction of the computer, so that every one of you will be on the same page, so that if anyone doesn't have much of the interaction with the computers before, so that they may know that what are the basic terminologies we use when we talk about computers and how the computers operate. And later on in the second part of this course, we will look at the programming, and we will specifically focus on the C++, and we will see how to write a program or perform the basic operations using programming. So we will start with the first lecture, history of the computers. So we will talk about how computers have been evolved with the passage of time, and how the word computer came into being. So the topics covered during this lecture will be the definition of the computer, earliest computers, we will talk about them, its history, and computer generations. So I will just focus on, you can say quickly focus on all the things here. All the slides have been made very much, you can say, in the elaborative manner. So I will quickly go through so that you may not have to spend a lot of time seeing these lectures. So a computer is a programmable machine. Alright, so a computer is a programmable machine. A computer is a machine that manipulates data. Alright, and according to the list of instructions, a computer is any device which aids humans in performing various kinds of computations or calculations. So the basic idea here is that it has a calculating power. Alright, so its calculating power can be used as we want with the list of instructions. Alright, so it's not that it can perform only specific tasks with that computing power. We can define how to use that computing power and utilize it in many different ways according to ourselves. So this is basically what a computer is. Alright, so it aids humans in performing various kinds of computations, follow the human beings, and aids and helps him in working in different calculations or computations. Three principal characteristics of computer: it responds to a specific set of instructions in a well-defined manner. Alright, so whatever instructions you will give it to him, it will cover up those instructions or fulfill those instructions in the defined manner. Alright, so it is not that it will carry on few instructions and just skip others. So there is a set pattern to it, and it will follow that instructions whenever we give it to them. It's not like it will follow sometimes and doesn't follow other times. Alright, so it can execute pre-recorded list of instructions. So we can use the pre-recorded list, or we can manipulate every time a new list of instructions for the computer. It can store and retrieve large amounts of data. So this is also, you can say, another utility of the modern computers. So we are all familiar with the computers, mobile phones. They have a lot of memory, and now you can say we are storing data in 1 terabytes, 2 terabytes. You can say the size of the storage capabilities of the storage devices is going on increasing as we are moving more towards modernity. So earliest computers originally were used for calculations. Originally calculations were computed by the humans whose job title was computer. So basically the word computers come from you can say basically a job title. Alright, so it was basically kind of a job title, and persons who performed, you can say, calculations, who calculated things, were usually called computers. Alright, so basically computers were humans. So these human computers were typically engaged in calculations of the mathematical expressions. So these are like skilled people, and which can calculate or use mathematical expression to calculate it for the other people. So then these persons were called computers. The calculations of this period were specialized and expensive, requiring years of training and mathematics. So basically, these you can say these jobs as computers were highly skilled and requires a lot of training and the mathematics. The first use of the word computer was recorded in 1613, referring to a person who carried out calculations or computations, and the word continued to be used in that sense to the middle of the 20th century. So, like 100 years before, the word computer was mainly used for humans that used to do a lot of calculations based on, you can say, mathematics. So, tracing back the history of the computers, we can say that earlier humans used tally sticks as an ancient memory aid to record the document numbers and quantities. So we know that modern computers store a lot of information, alright? So our human mind cannot store a lot of information, or you can say the permanent information. There is a probability that we can somehow forget some information, alright? So there is always a possibility to write it down for some permanent storage. So earlier computers used these, you can say, the bones of the people and the bones of the animals, you can say, and used to write some letters for the memory. Right? So these bones or tally sticks, or you can say the wood carvings, were used earlier so that they could aid in memory. So we have just learned yet that the computers usually do store a lot of memory, right? So we use computer to store large files. We have PDF files, we have MP3 files, we have lot of kind of data. We use computers to store our data. So in the ancient history, we don't have the computers of the modern times, so they used these sticks and some patterns on them to have their data stored. So Abacus, a mathematical mechanical device, was used as an aid for an individual to perform mathematical calculations. Abacus was basically a mechanical device, which was used to perform mathematical calculations, or you can say ease out mathematical calculation. The abacus was invented in Babylonia in 2400 BC. So it's currently, you can say, 2020. So you can just see how much old it is. So it's almost 2000 years this and 2400. So it's almost like you can say 4420 years ago. So it was kind of a very old device which humans used for the calculations. The abacus in the form we most familiar with was first used in China around 500 BC. So the abacus we kind of know is around 2500 years old. So it was used to perform the basic arithmetic operations. So this is a general overview, or general, you can say, the perception of the abacus. These are like the previous abacuses, and these are the modern abacus. So it consists of a lot of you can say the panels here, and you can number each one of them as you can say ones, tens, or hundreds, and the movement up and down or left to right will indicate the number of things happening. Another one of these devices that has been used in the history that we can say relate to the history of the computing is Napier bones. So it was invented by the John Napier in almost like 16th century. And also use these bones, and they were like tables, and they can perform the basic the multiplication, divide, calculate, square, cubes, using the pre-calculated constructed boards. Alright, so if we want to multiply, we have to use specific calculated, you can say, boards or bones, and if we want to divide, we have to use the specific ones. So for every operation, there were different set of you can say boards which were designed based on the idea of the John Napier, so which helped humans make difficult or time-consuming multiplication and divisions in relatively easy manner. Similarly, we had a slide rule. It is a device with the pre-calculated, you can say, these tables here, up and down. So you can slide up and down here and multiply division, roots, logarithms, and trigonometry. And all can be performed using the slide rules. Similarly, there was Pascaline, invented by the Blaise Pascal in the later part of the 16th century. It is also a mechanical device. Due to its mechanical nature, it's kind of complex, but it can also do a lot of multiplication and addition and subtraction. Similarly, there is a stepped reckoner. So these are all the mechanical devices which use the rotated, you can say the rotation and the gears to move different, you can say, wheels to do the subtraction, multiplication, and division automatically. So the loom is basically a mechanical, you can say, machine, a mechanical loom invented by Joseph Mary Jacquard in 1881. So in the later part of the 19th century, he invented the mechanical loom that can take instructions using a punch card. So a punch card is basically, you can say, a card where some holes could be made at the specific locations. The machine can read these holes and do some specific tasks. So arithmometer. So it is also a mechanical calculator invented by the Thomas de Colmar in 1820. So it is first reliable, useful, and commercially successful calculating machine. These machines could perform 4 basic arithmetic operations. So you can see that there is kind of much of the limitations because of the, you can say, because there were no the modern semiconductors or electronics were present. So the devices they used were really mechanical. So there was not much, you can say, the efficiency as compared to the current world calculators we use. So the difference engine and the analytical engine. It is an automatic mechanical calculator designed to tabulate polynomial functions. So it was, you can say, the most complex form of the mechanical system or mechanical computing device that has numerous large gears and levers that one can engage and do the polynomial functions and calculation. Right? So its complexity was very much, you can say, increased, and this was mostly referred to as the first mechanical computer, and it was invented by Charles Babbage, and really he is known as the father of computing. So the first program was designed by a female lady named Augusta Ada Byron. Maybe I'm not that familiar with the pronunciation, if it's French or any other, you can say, nationality, so its pronunciation may differ about that. So she writes a program for the analytical engines. So this kind of program was really to how to operate and what to do and how to get the, you can say, the desired answer or the desired result from the analytical engine designed by the Charles Babbage. So this is another calculation engine. So it's also based on the difference engine. So but it was usually referring to the, you can say, using the same technologies on the printing press. And so others are tabulating machine invented by the Herman Hollerith in 1820 to assist in summarizing information and accounting. So Havard Mark 1, so also known as IBM Automatic Sequence Controlled Calculator. So this it was invented by King, and the first electromechanical computer. So these computers, we can say, we are moving on into the 20th century. So these computers used the, you can say, the electromechanical devices. Alright, so even up to 1943, There are no, you can say, the semiconductors or transistors here. So these computers are really very big. You can see about that. So it is a full room, and you can see it's very big as compared to the human standing here. So this is also another computer, Z1, the first programmable computer created by Jacquard Loom in Germany. So the user insert a punch tape, so it's kind of like a tape with punches at different places, and the machine could read these punches and perform operations according to these punches holes, and trigger the specific, you can say, uh, gears and everything. Atanasoff-Berry Computer. It was the first electronic digital computing device invented by the professor John Atanasoff and graduate student Clifford Berry at Iowa State University. So it's also kind of before 1950, and these are all, you can say, the basis of the modern computers. You can say the elementary computers that put, or that you can say, made the modern computers possible. And this is another computer. ENIAC stands for the Electronic Numerical Integrator and Computer. It was the first general purpose computer, completed in 1946. So this is also, you can see, very huge and not so user friendly. So there is another computer, UNIVAC 1, the UNIVAC 1 Universal Automatic Computer. It was also the first commercial computer. EDVAC. So EDVAC stands for the Electronic Discrete Variable Automatic Computer. So these are all the computers, and you can go through the you can say, its specific details. We are just looking here so that you may understand how this evolution take place in the history, and we moved from, you can say, a low efficiency to the higher efficient machines that we currently have. So I will just quickly go through about that. The first portable computer in 1981, the Osborne Computer Corporation. So you can see like it's in 1981, and it's fairly simple, and you can say fairly portable as compared to the other computers. The first computer company was Electronics Control Company, founded by the J. Prosper Eckert and John Mauchly. So there are 5 generations of computer. The first generation is we term it as 1946 to 1958, and then the second, third, fourth, and fifth generation we usually refer to, you can say, the today world is the 5th generation. So what are these generations and what it means? We will see about that. So the first generation of the computers used the vacuum tubes for the electricity and magnetic. So first generation, and we already have seen it begins from 1946 to 1958. So these used the vacuum tubes. So these are the vacuum tubes, and they can conduct electricity based on the gas. So so these vacuum tubes were used as a switch. Alright, so later on these vacuum tubes were replaced by the transistors. They were very expensive to operate, and in addition using a great deal of electricity. So there were a number of, this has a sizable, you can say, proportions. So using these in large quantities in computers usually end up being very big and cause a lot of heat and malfunctions also, right? So if one of them could, you can say, break off or shut down due to the heat, so they cause a lot of malfunctions also. So these first generation computers relied on the machine language, the lowest level programming language understood by the computers, to perform the operations. So they could only solve one problem at a time. So they don't have much of the, you can say, the computational power, and to program these you have to know you can say every nitty-gritty of the computers. So like it was not that easy, just like the modern computers of today, for anybody to just come and program it. So these use machine language, so which is very difficult and complex to implement for everyone. Input was based on the punch cards and paper tape, as we already discussed with what it means, and the output was displayed on the printouts. So our inputs were also, you can say, the punch cards and paper type inputs, and you can say the printouts or paper types output, not like the modern ones we see, like monitors or something. So the second generation, the transistors replaced the vacuum tubes, and I showed the second generation computers. One transistor replaced equivalent of 40 vacuum tubes. Right? So you can see that this tiny component was used instead of the 40 vacuum tubes. So the computer becomes a lot smaller and faster, and even cheaper. Alright, so instead of like 40 things, you have to manufacture only this small equipment. So it also becomes more energy efficient and more reliable. Still generated a great deal of heat and can then damage the computer. But the second generation computers moved from the cryptic binary machine language to symbolic or assembly language. So there was, this is, you can say, the one step forward. Assembly language is, you can say, relatively much easier to understand for, you can say, the outside, and you can say the commercial users, which allow the programmers to specific instructions in words. Right? So the assembly languages, the use of assembly language was a plus point for the second generation. The second generation computers still relied on the punch cards for input and printouts for output. So the input and output methods still remain the same for the second generation. And these were also the first computer that stored the instructions in their memory, which moved from a magnetic drum to magnetic core technology. So the storage capacity is also, you can say, the change. So magnetic cores were used for the storage purposes. So the third generation, the development of the integrated circuit, or IC, what we usually refer it to as, was the hallmark of the third generation computers. The transistors were miniaturized. It means that the transistor we seen earlier, its shape was minimized and placed on the silicon chips called the semiconductors. Right? So semiconductors now come into the play here, which drastically increase the speed and efficiency of the computers. Much smaller and cheaper compared to the second generation computers that carry out instructions to billionth of a second. So these were, you can say, the very efficient than the second generation computers, and you can already see the size here compared to the second generation transistors. User interacted with the third generation computers through keyboard and monitors and interface. So we can see here that the keyboard and monitors, the input and output, instead of the punch cards, we now have the inputs using keyboards and monitors. And the operating systems are also there, because we have the monitors here, which allow the device to run many different applications at the same time. So there is also, you can see, the more computing power, as we have seen that they can compute the billionth of a second. And computers for the first time became accessible to the mass audience because they were smaller, cheaper, and cheaper than the predecessors. So you can say that these were almost the first computers that everyone could buy, or they was relatively cheaper for everyone to buy. The fourth generation, the microprocessor, brought the fourth generation of the computers, as thousands of integrated circuits were put into a single silicon chip. So we can see that these are one integrated circuit. All right. So the number of these integrated circuits were combined and put in just one of these chips, which is called the microprocessor. All right. So as thousands of integrated circuits were built on a single silicon chip, as these small computers became more powerful, they would be linked together to form networks, which eventually led to the development of the internet. So these were, you can say, the fourth generation computers were capable of interacting with each other and form the network. So these computers led to the you can say the development of the internet we know today. The fourth generation computers also saw the development of the graphical user interface. So graphical user interface. So all the computers we now have the graphical user interface. Graphics are the things we see. So everything we visualize here and the operating system, the Windows is basically the graphical user interface. So we see my computer and we click on that. So this is basically the graphical user interface. On the previous ones, there was no graphical user interface, and you have to give the commands based on the text. Alright, so there was no, you can say, the visual appearance of anything. The fifth generation, the based on the artificial intelligence. So it's you can say the current world is the AI based, and you can say it's still we can say we are still here, and this phase the AI is growing and becoming stronger and stronger. Artificial intelligence. So artificial intelligence really you can say capable of learning and self-organization. So these computers are capable of learning themselves about the, you can say, the more efficient methods, or about the more efficient ways of doing things than, you can say, the previous models. And they use the parallel processing and superconductors is helping to make artificial intelligence a reality. A goal is to develop the devices that respond to natural language input. So we already see that now the computers, we speak to the computer, we can dictate what to write, right? So for example, we use in the mobile phones, we can use Google or Siri. You can say that these are basically, you can say, the natural language input, and these systems are capable of self-developing and understanding what we are saying based on this artificial intelligence. So these are becoming stronger and stronger day by day. There are some applications. There are some applications such as voice recognition, and they are being used today.